Okay, just have the marking scheme on the left. When I need it, I'll just pull it out when I need it. Okay, so we throw it at 2 root 2 to the horizontal. So plane's inclined at 45 degrees to horizontal, right? That's your 45 degrees there, isn't it? If I use that information straight away, I can do my gravity triangle straight off, can't I? So the great thing about 45 degrees is you can't go wrong. So that's going to be 45, and that's going to be g over root 2, and that's g over root 2. That's g cos 45 and g sin 45, okay? Alright, so all that's used already. Particles drawn down with the plane with initial speed to root 2, I can see that, and angle 45 degrees to the inclined plane. The fact that it's 45 degrees means what? It's actually thrown parallel to level ground, isn't it? When you throw it at an angle similar to the plane, it's going to be the same thing, okay? The range along the first plane, the hop is D. That's a hop. Look, they're using that language again. The range along the inclined plane of the first hop is D. So what's that telling you? That the throw is included as in hop, which is wrong, but that's the way they're treating it. Okay? But it is fairly obvious in the question, isn't it? Right. So, and then the plane of projection sphere contains line of ground slope. Grass is green, sky is blue, is all that means. It just means business as usual. Okay. Find the value of D. Alright, no worries. Let's do this. What we're going to do is we're going to do Vx and Vy. Now, we're gonna draw parallel to the plane. We have our 45-degree throw. And that means 2 root 2. It's going to be 2 root 2 cos 45 and 2 root 2 sine 45. And what does that turn out to be? Just 2 and 2, isn't it? So there we get 2 across and 2 up. Right. 2 across and 2 up. 2 and 2. Now, we're going to do our Vx equation and Vy and Fx and Fy. So Vx is going to be 2. Now it's plus gt. So g over root 2. A Vy is 2 minus g over root 2t. Sx is going to be 2t, then half the second one. So it's going to be g over 2 root 2 squared. Sy is put t beside it, so it's going to be 2t, half the second one. Then you get g over 2 root 2 t squared. We all good so far? Okay. Next thing, find the value of d. Well, it's when sy equals 0, correct? And then I have to find the sx value. So sy equals 0, find sx. No bother. So sy equals 0. We're going to get is 2t equals g over 2 root 2 t squared. Cancel the t's. And we're going to get 4 root 2 over g equals t, or time of flight. Let's have a quick peek here. 4 root 2 over g. Yep, we're all good. Yep, that's the first part done. No bother. Okay, we're currently correct. Next thing we do is we put into sx, and we get sx equals 2 times 4 root 2. 4 root 2 over g. And then plus gt squared, so it's going to be plus g over 2 root 2. Now it's going to be this thing squared, so what happens when you square that? 4 squared is 16, root 32 over g squared. Okay. Now, what should happen here, we take the lazy way out. I'll see if the lazy way out works. for the go on occasion, especially first thing in the morning. 2 times that is 8 root 2. Would everybody be happy with that? I'm just ignoring all the letters. Plus 1 divided by 2 root 2, is it? 2 root 2. And multiply that by 32. 16 root 2 for everybody. So Sx is going to be 16 root 2 over G. Because the 2 then cancel. Okay. Once again, feel free to 16 root 2 over G. No bother. Does it want it in decimals or anything like that? You could sub in 9.8. And if you sub in 9.8 for G, you will get 2.31. Did anybody get 2.31 instead? Yeah. So 2.31 if you sub in 9.8. Everyone bored so far? Will you dim the lights, by the way? Cheers. Yes. It doesn't specify. It doesn't specify if it wants it in terms of G or not. So I'd imagine both answers are fully acceptable. Okay. The coefficient of restitution between the particle and the inclined plane. So the E value is 0.4, and the range of the second half is KD. Find the value of K. All right. So what I'm going to have to do is I'm going to have to find out what happens at the blue part. I'm going to need my Vx and my Vy at the time of impact. So I'm just going to write down my D value up here. My D value is 16 root 2 over G. I'm just going to keep that stored up there. I'm also going to keep my time of flight. Everybody see the time of flight to the right there? 4 root 2 over G. Going to need that as well. And now what I'm going to do is I'm going to insert it into Vx and Vy. So Vx is going to be Vx. What we're going to do here? Vx is going to be 2 plus G over root 2 times T, which is 4 root 2 over G. Anybody get a 6 for that? 6. Alright, that's very on the easy side, isn't it? Alright, what about Vy? Minus 2. Am I cool with that? Now, so if you take a snapshot of what's going on, is that you're about to hit the bounce, and you're coming down, and then you're going to bounce back up. Now, you're coming down with 2. You're going down with 2 and across with 6. You're going to continue across with 6, but what's going to be the rebound of the J component? 2 times 0.4, which is 0.8. Now, do you remember the 4 equations we had earlier? These guys here. You can be really lazy because what's exactly the same? The gravity components are exactly the same, aren't they? So, you know me, I love a good shortcut, okay? So I'm just going to, oh dear. I'm going to drag these down here. Alright, and what's the only thing I'm going to change? What's the only thing I need to change? Just to change the 2's. And you're good. You're good to go then. So, the Vx is going to be 6, isn't it? So that's going to be 6 and 6t. And the other one's going to be 0.8 and 8t. Everything else is the same. So you don't need to worry about anything else, okay? Now, once we find the range of the new one, yeah? So let's find the range of the new one by getting the time of flight. The time of flight is 0.8t equals G over 2 root 2, is it? 2 root 2 t squared. Okay, now what? Cancel the t's. And then after that, 0.8 times 2 root 2 It's not a bad one, actually. 8 root 2 over 5. Is there a G there as well? Over the G. Yeah. That's your time of flight for your second one. Put that into your SX and you should be good to go. So SX is actually, do you know the fact that you're going to divide your new range by your old range to find the K value? So imagine the initial range was 50 meters and your new range is 150 meters. You divide 50 into 150 and your K value will be 3 because it's 3 times bigger. So rounding it off might have actually worked. Using decimals could work against you here. Thirds would be the more accurate way to go. Okay, but if you did round it off to decimals and you got like something like 2.999, you could just say it's a 3 because of the rounding. Okay, but thirds would be the more accurate way to go. So here's our start as a fraction. Which would end up as a third. Never mind. Put it into SX and we get 6 times 8 root 2 over 5G plus G over 2 root 2 T squared. T squared is going to be 64 times 2, which is 128 over 25 G squared. I'm going to do what I did last time. I'm going to ignore the G's existence and just put everything into the calculator. Thinking gives me wrinkles. Now, plus 1 divided by 2 root 2. Yeah. 128 over 25. And close it. Oh dear. So, it appears I'm going to have to keep my own swords now. Okay? So, Shakar, keep my own swords. Great. Alright, 48 root 2 over 5. 5G. And then 264. 64. Oh, that's annoying. Give me a second. 128 divided by 2 root 2. I'm going to calculator doesn't do it for you. 2 root 2 root 2. Okay. Solution. Anybody? Common denominator. Put it all over 25G, wouldn't you? All over 25G. You know your answer is going to have a root 2 in it. 5 times 48 is 240. 240 plus 32. 272 root 2 over 25G. Then I'm going to go to the very top and I'm going to see 16 root 2 over G. 16 root 2 over G. Which one's bigger? Do you reckon? Yeah. Alright, let's find out. This one, I'll divide by 25. Divided by 16 root 2. Hope this is right. I'm just ignoring the G's, haven't I? They're just going to cancel each other out anyway. 17 over 25, anybody? So it means that it's smaller than the original. Yeah, it's 70 and 25ths of the original. Who got that one out last night? Right, good job. All right. Go. I think it's easier to just like